Relax Babe is dedicated to making CBD wellness easy, delightful, and routine by harnessing the power of full-spectrum CBD into pre-dosed, delicious, third-party tested gummies. Formulated by a team of organic food experts in California, Relax Babe CBD gummies contain only 6 simple ingredients, including the highest quality Colorado-farmed sativa indica blend hemp to specifically address stress, sleeplessness, pain, and inflammation morning or night. Use coupon code FINDINGGENIUS for a 20% discount at checkout. Visit shoprelaxbabe.com to shop now.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Steve Allen and Deonie Allen. She goes by D. Their husband and wife team. They're leading research on atmospheric microplastics. So we're going to talk about their work. So Steve and D, thank you for coming.
Thanks for having us.
Yeah, thank you very much.
What did you guys think about and decide to study microplastics? What's your background?
Well, Dee and I are both sailors and paraglider pilots, so we spend an awful lot of time out in the wilderness and the remote areas of the world, and we could see that plastic was becoming more and more obvious. Whereas once upon a time you would go to a beach on a remote island and see a few bits of rubbish off the fishing trawlers, all of a sudden there was plastic bags and water bottles, and it was just getting worse year after year. So that's what sort of prompted us to move into microplastic research, was knowing that there's so much of it out there, it has to be breaking up. Where's it all going?
Well, one thing, D, before you start, has there been a location in the world that's been super remote that hasn't had any plastic, or is it now everywhere you guys go?
It's absolutely everywhere. We've seen plastic water bottles floating 1,500 nautical miles from land. We've been on beaches in Saguaro Island in the Cook Islands, which is 600 nautical miles from anywhere, but the beaches are covered in plastic. It's just, there's nowhere left on the planet.
Oh my God. All right, well, I'm sorry about that. Dee, please tell me about your background. I apologize.
No, I was just about to chime in and say exactly what Steve said, that we were 1,500 nautical miles offshore. So basically halfway between the United States and the Marquesas, and found plastic floating in the sea as we were sailing along, which was quite devastating, really, because it's not supposed to be there. I'm an environmental scientist. I've done environmental pollution my entire life. So yeah, that's how we came into this. My PhD is in environmental pollution, anthropic environmental pollution. So that's pollution created by people, and doing the transport of where it moves to. And we landed up doing a postdoc job in France. And one of the sites that I was looking at for my postdoc, which was not in plastic, we started seeing plastic in some of the samples, or what looked like plastic in some of the samples that we were getting. And that's the Pyrenees study that was published in 2019. We saw these artificial particles and thought, how did that get up there? Like, these are atmospheric samples. What's going on here? So that was our first, I guess, foot in the door of being able to actually do some plastic research.
The pilots in us understood how it was likely to get there.
Yeah,
using convection.
We just have to prove it.
When you're saying atmospheric microplastics, like, where did you see them? You know, I know they're in water quite a bit, bodies of water, but did you see them in the air? Like, where did you see them?
So we were on the top of the Midi-Pyrenees, so that's the middle section of the Pyrenees that's near Toulouse. And my study was looking at sediment cores, but alongside the sediment cores that are taken from a catchment that's at the very top of the mountain. So there is no upstream area that can sort of like have this running off over land to get to it. It's at the very, very top of the mountain. But there are also what we call ombotrophic peat cores. So this is peat, which is organic material that grows in hollows in the ground at altitude, generally when it's a little bit cold. And ombotrophic peat only gets water and nutrients, so it only gets its growing material from the air. That's the unique thing about ombotrophic peat. And we were looking at the cause of embotrophic peat to try and look at and the sediment cause to try and look at the history of erosion and sort of metal influences and things on the top of this mountain. And in those archives, so those are used predominantly to age date back through time to show you the change in pollution and like erosion and other things back through time. So you can go sort of like in 10 or 5 year blocks back to the 1950s and way back before that. Like you can go, thousands of years into history backwards by looking at these archives. And we found plastic in those archives looking backwards. And that's when you kind of go, okay, we're looking at something that is purely fed from the sky and has got plastic in it. So clearly this has been dropping on us for a while.
I'm sure I've heard of microplastics and also nanoplastics. And I'm sure in the right conditions, various molecules aerosolize. And, I don't know what the dynamics of the atmosphere is if they clump together, but I know that, things get electrostatically charged as they move through the air. I wonder if the processes of cloud formation and rain and all that, how that interacts with these microplastics or nanoplastics.
Exactly the thinking that we've been having for quite a while. And a lot of it is just, we don't actually know what this stuff's like in the atmosphere. The triboelectric effect, as you say, with the wind fastening the particles is probably going to give it an extra charge. We don't know if it's positive or negative. There's a lot we don't know. But the thinking is, and Laura Revell in New Zealand recently published on the possibility that these micro and nanoplastics could be affecting climate already because of their presence in the atmosphere, either absorbing energy or reflecting it back out, depending on the altitude. And she based her numbers on 100 particles per cubic metre, and we're already getting 5,500 in places in China, which means it's likely already having an effect.
Well, I was imagining a car, the exhaust from a car. I wonder if along the path of, an engine processing gas and along the exhaust path, if there is any plastic fasteners or anything, and the hot exhaust, and maybe it's corrosive, would shear off plastic from, let's say, the insides of a car somewhere, and it would, help contribute to putting it into the air. I just wonder how much transportation of vehicles help create this, or if it's coming from another source. Like, where would it come from, do you believe?
It's much bigger than that. So it's not just the stuff that's coming out the exhaust. It comes out of your exhaust. It comes off your tires. So as the tires move across the road, you get tiny little microplastics that come out and become entrained. It comes off the road. So all road paint, predominantly, most road paint has got a level of plastic in it because it sticks really well and it's quite hard wearing. So it's off your plastic on your road. So every time you roll over that, and every time there's any kind of friction or acidity in the rain, blah, 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 they degrade, and that those small particles are able to be entrained. When those particles are in water on the road surface, the raindrops that hit them help those particles become entrained into the atmosphere. So Moritz Lehmann's done some really nice research where he's both mathematically shown, and his partner, whose research name is, I can't remember, but the lovely lady that works with him has done the physical study to show the particle droplet impact and how much plastic actually comes back out into the atmosphere from that water when the drop hits it. So you get water going back up, microplastic going back onto the atmosphere following that route. It comes off your clothes. So if you're wearing like plastic clothing, which most people do, so if you're wearing your nice little polar fleece, whether it's brand new or whether it's recycled plastic, when you rub it, the plastic particles come off and release into the air. It comes off the carpet, it comes off the plastic flooring, it comes off the plastic that's in the paint that you've painted your walls with, it comes out of your curtains. It's everywhere, and every movement we make helps entrain this plastic up into the atmosphere. And it doesn't need an awful lot to get up and get entrained. These particles don't have a very high density. So if you think of things like Saharan dust, when the Sahara has a storm, we'll end up having like the Alps and the Pyrenees and all the way over in America being covered in like that orange dust, right? These particles are potentially of similar size, but they're half the density and they're in a whole range of different shapes. So it takes about 13 days for some of these teeny tiny particles from like Saharan dust type scenarios to go around the world. Therefore, the likelihood of plastic doing the same thing is potentially quite high because the dynamics of what we know about the particles so far suggest that it's going to move at least as easily as that.
Have you or anyone done an experiment? Let's say you get a piece of plastic and you sit it in the sun, the wind's blowing over it. I would think the sun let's say I'm imagining the sun, hitting these molecules and, breaking some of the bonds on the surface. And then I wonder what these molecules of plastic would naturally attract, or if that allows them to like agglomerate and become bigger. It serves as like nucleation sites. Has anyone looked at the dynamics of exposure to sun and all these different kinds of plastics?
Yeah, I think most of us have done our own amateur experiments in our backyards with our garden furniture.
Just to see, yeah.
We've all seen plastic degrading in the sun, and we're 100% certain it does, whether it's just the ultraviolet light or added salts or other chemicals. They all play a part in its degradation, and what happens to it after that is still a bit of a mystery, because like if you put the negative charged plastic in fresh water, when it moves to salt water, it becomes positively charged. It just it messes with your mind, trying to work out exactly what's going to happen when you put this in the atmosphere. Will it attract dust particles and therefore affect cloud formation in that way, or will it repel the dust? We just don't know yet. There's too many questions.
At the moment, this is like, as far as science goes, this is really cool, right? We have a brand new particle that is unlike anything else there is in the world. It doesn't have a proxy. It doesn't act the same way as black carbon or dust or soot or anything else like that. There isn't anything out there. It's not like mercury. It doesn't have a single species. It doesn't stay the same charge depending on what type of plastic you've got. The content, so the ingredients list that's in each type of those plastics, is different, and there's thousands and thousands and thousands of different additives that get mixed and matched for different types of plastics depending on who's made them, what they're used for, and nobody knows or publishes what those ingredients lists are. So they degrade in a different way. So they change their shape, they change their size, they change their charge. Some of them better at adsorbing or sorbing, I should say, the pollutants on the outside of them, or creating eco-coronas. And that occurs at a different size in particle as you go down in the particle size range. So as it gets smaller, certain particles become better or worse at doing this. Like, it's unlike any other particle we've ever found. It's really cool, but at the same time, utterly terrifying and really difficult to parameterize, because we are literally dealing with a population that's got a whole heap of different species inside it, and each species has got its own unique characteristics, which we have to somehow kind of put a box around the outside of so we can start to understand and more accurately model how these particles move. And we haven't done that yet, because atmospheric plastics literally started in 2015. Nobody knew about them before then. So it's only been going for a short while.
What about in estuaries where you have salt and fresh water mixing? That might be a good place to look and see the dynamics. Maybe there would be, a mass accumulation or an exclusion of plastic from those areas.
Yeah, they're doing some really good work on the hyperbaric exchange and whether flooding actually pushes the plastic down into the mud, or whether flooding will then lift it back out again, because, with climate change coming, we're getting more and more severe flooding mixed with large periods of no rain, which speeds up the degradation, and the plants that are normally lining the bank start to die off. Plastic gets exposed, the flood washes it into the river, and then it's just the scenarios you go through. There are thousands of different ways that stuff can move. And even just as a macroplastic, they're throwing plastic bottles into water with GPS trackers on them to follow and see where it goes and how long it takes to get out of the river. And some of them are finding that it's actually staying in the estuary. It's just going in and out with the tide and with wind, and takes a really long time to even leave the estuary.
However, obviously, there is quite a lot still getting out, because we have an awful lot of plastic pollution in the marine environment, which has come from our rivers.
And the air.
And the air.
Relax, Babe gummies are vegan, organic, all-natural, and infused with CO2-extracted hemp to provide the purest, best-tasting, highest quality CBD to support and aid your body's endocannabinoid system. Try their variety pack today and make everyday wellness within reach. They're offering our listeners a generous 20% off their first purchase. You can use coupon code FINDINGGENIUS, no spaces in it, FINDINGGENIUS, at checkout to save 20% site-wide. Just visit shoprelaxbabe.com. Yeah, that's what I was going to ask you, is has anyone been able to make a map of where plastic tends to go? Like in your travels, have you been able to just anecdotally see, these two remote areas, they're both remote, but this one seems to accumulate a lot more than another? Has anyone mapped the Earth and seen where the sinks are for plastic?
We don't have enough data points for that yet, but we'd like to.
Yeah, that's the aim, right? So, we've got a new paper that's hopefully coming out shortly ish, that's trying to sort of instigate the global, slightly more standardized way of doing some analysis so that we can start creating this global map of, where are we at now and where are the hotspots? Where does it most likely that we seem to find more and under what conditions, so that we can then work backwards and try and figure out why. But yeah, I mean, we've got the gyres in the marine environment, but as far as atmosphere stuff goes, we are still way under data.
Interestingly, though, some of the studies are finding more fibres and some of them are finding more fragments. And it does seem to be depending on how far it is from the city.
Yeah, and the particle size that they're looking at. Because as you start going down to sort of like the PM 2.5 and below, so the respiratory size, the differentiation between what's a fibre, like as in like what's classically a fibre, what started out to be a fibre, what breaks down to look like a fibre, and what's broken down so far that we actually can't tell whether it's a fibre or not, becomes quite blurred. So, yeah.
Is there any, I mean, even though you don't have all the pieces of the puzzle or many of the pieces, what's jumping out at you already? Does it appear to be uniformly distributed plastic, or is there big lumps and clumps of it, in different spots of the world? Any ideas, any initial thoughts?
It does seem to point to waste management quite heavily. There's issues with places like China and unfortunately Vietnam as well, where the waste management is incredibly poor. Indonesia, for example, they tend to burn the plastic. They're using it as, there's one report came out recently where they were burning the plastic to create energy for a tofu plant. And the plastic, the dioxins coming off it, were actually contaminating the tofu and contaminating the eggs of the chickens in the area. So the people were actually eating a lot of dioxins, like 75 times the legal limit, because of just poor management. And when you burn plastic, it does release microplastics and nanoplastics. How effectively, we're not sure yet, but we're still working on that.
Yeah. So basically, we have a blanket of plastic around the Earth, and it seems to be that we have plastic throughout our PBL. So between like surface ground layer and where the clouds are at, we have like a blanket of plastic inside that area. We also have plastic above the clouds. So we've managed to get samples that are above cloud, but also to illustrate that it's traveling, it's getting up and down and above the cloud area. So, up where the planes fly, basically, and that there is mixing going on. And that's quite worrying because things travel an awful lot faster above the clouds than they do below the clouds. We're also noticing that there seems to be, like, cities are obviously a key source of plastic. We create a lot because where we have an urban area, we create the plastic because, well, we are the plastic polluters. We are the direct source of all plastic problems as humans. But we also have an awful lot of in agricultural areas. But the source-specific release rates, the theory currently is that it's a socioeconomic location, sort of like seasonal and environmental parameterization that you need to get done. Like all of those elements influence how much is released from different areas, from different sources. And one of the major pushes forward in the research at the moment is to try and quantify those sources. But it does look like we are emitting a lot out of anywhere there's a human. We're emitting plastic, and anywhere we do any sort of agricultural work, anywhere there's industry, anywhere there's a city, we're basically creating little plumes. And where we originally back in like 2015, 2016 thought that there was just a little bubble of air around the cities where the plastic was, what we're seeing is that, okay, so we have cities and places like that have strong high levels of plastic, but actually it's basically dispersing out from there and going absolutely everywhere. So, even in Antarctica, in the Arctic, and at the top of some of the remote mountains across the world, we're finding plastic. And most of the time, what we seem to see is the further away and the more remote you are, you may not necessarily get less or more plastic than you would find in other locations, but you get smaller plastic because the small stuff seems to travel furthest.
Is there anything you can use to collect plastics in a certain area, and a sponge or something that you can unwrap and leave out for a little bit and then sample in the lab?
We've got deposition collectors and air pumps and all sorts of things like that. You can try it at home if you've got a good magnifying glass. You probably actually start looking around on your table. You can buy, the UV LED torches that they use for finding pet urine and stains and things like that. Those will actually show up plastic. You can turn the lights out and shine it across your dining room table and you'll be pretty surprised.
Yeah, you'll be terrified. It's
how
like
many
little
plastic
bits
particles
everywhere.
there are, yeah.
Yep. We do it to test our cleanup.
How do you know it's what does dust look like under those lighting conditions versus plastics? Like, how can you tell? Or is it obvious?
It's pretty obvious.
Really obvious. Yeah.
There are some natural things that fluoresce, like chitin fluoresces crab shells. So if you're going to have crab shell on your dining room table, then
you might
it
want to
will
clean
fluoresce.
it. Yep.
But plastic tends to fluoresce quite brightly. You'll see it really quickly.
Yeah, it looks a little bit like some of the photos you get in Nile Red papers. Basically, everything will be dark, and then you'll get these like little stars in your image, like, you know, these little things that pop up and just look really shiny. That's plastic.
Have you guys been to any of the garbage patches that are around in the ocean? I forgot to ask you that earlier.
No, we haven't.
Not on purpose. We may have sailed through one, but not
the big
sampling.
gyres.
Yep.
Have you ever thought about sailing out to the gyres and seeing what they look like firsthand?
Yeah, I mean, they're not very exciting to look at. It's more of a plastic soup, so it's not like some of the images that you've seen of the plastic gyres are actually just taken at the river mouth where lots of plastics coming out through flooding. The gyre is not that exciting.
Unless you look at it under a microscope, and then it gets exciting.
There's a lot more on-land plastic dumps that make the gyres look a lot like cleaner. Like a lot of the rich countries are sending all their plastic to low and middle income countries for disposal or recycle. And, you know, this is a complete myth. If the rich country can't afford to set up a plant to recycle this stuff, there's no chance that a low or middle income country is going to do that. So sending the plastic to Africa, you're creating plastic gyres on land. And the difference is that it's coming back to the wealthy country, but it's coming back in the air.
Yep. And this is a problem. This is something that we need to start thinking about, because when it comes back in the air, it comes back as a particle that basically you are eating and breathing. And they've illustrated now that we are eating and breathing plastic. It comes out in your stool, and they've found it in placentas and things like this. So we know that we have plastic through our bodies. And these tiny little plastics that are in food, like that we're eating and that we're breathing, non-food grade. So that's the refuse and everything else that's been eroded by the natural environment conditions, by the mismanagement of plastic, that you'll now have on your toast or in your milk or in your beer or in your salt, that you're breathing when you go for your run in the morning, that isn't designed for human consumption. So when you throw your plastic out and then it goes to get recycled wherever it is that it's going to get recycled, if it doesn't actually get managed properly, then it does come back to you, and it will come back to you probably in a way that you can't, it's not beneficial, shall we say.
We have food grade plastic, and it's supposedly safer.
Yeah.
But like things like car bumpers, nobody cares what goes into a car bumper because you're not supposed to lick it.
Yeah.
If you start licking your car bumper, you've probably got other problems.
Not even just licking it, just being near it.
Yes.
Again, stuff will come off the bumper and you'll breathe it. So, like, I can see an opponent to this saying, well, you're not going to lick this stuff, it's safe. But literally just being in the vicinity of it or being downwind of it, it doesn't matter. You're still around it.
Yep. And this is the problem.
That's all plastic ever made. Even the stuff that we now look back and go, oh, did they really use that phthalate? Oh, that stuff is what's in the air now because it's all broken down.
Yeah. And once it gets to that really small particle size, so the big stuff like the macroplastic, your plastic bottles and your plastic bags, we can pick those up and we can put them into some kind of management system.
And we should. And
yes, and definitely we should. There should be mass cleanup absolutely everywhere, and we get rid of all of the really big plastic that's not being looked after. That would be the ideal. Unfortunately, when it gets down to the size of the particles that we look at, so when you start looking at the micro and the nano-sized plastics, you can't collect those. So if we put an air scrubber up in the world to try and collect all the plastic in the air, you'd basically collect everything. There's no way of you picking out, allowing things like the dust that you need to be able to create the atmosphere and the clouds and the rain patterns and everything. You can't separate it out. There isn't a collection system that you can put in the air to stop the plastic from moving around.
Well, not yet.
That's not currently a realistic thing. It's a bit like trying to collect the micro and the nanoplastics out of the water. You can filter it, but you're going to catch everything else. So you'll end up taking all the biota, all of the plankton and everything else out of the water. So you're basically sterilizing it and nothing can grow. And if you take water and make nothing grow in it, then basically life on Earth stops, right? So we have a wee bit of a conundrum, whereas we know that the big plastic is something that we should be looking after. We're not doing it very well. But once it stops being big and starts being small, we can't do anything about it. So we need to stop it from getting small.
The trouble is we don't know how small it actually gets.
Yes, that's it.
Once it gets really small, once it gets below 1 micron, we don't know if it's got enough kinetic energy left to be able to start to break up. Basically, once it's in the nano size, if it's, say, 100 nanometers, it doesn't come down anymore. It's not affected by our laws of gravity. It's on its own little world in quantum realm, and only Brownian motion has an effect on it.
So you can get it rained out. It will deposit if it lands up getting like airflows that come down, so it'll bring it down, and if it hits something, it might stick. But yeah, it comes down in rain and snow and things like that, but it doesn't act like a normal big Newtonian particle. And trying to, I guess, predict how much is where when you're dealing with something that's the quantum realm is quite complicated.
So, all right, what is some of the major research into microplastics? If it even exists, there is major research. What is it focused on currently? And is that going to illuminate anything for you guys, or is it, you'll need to do your own separate work?
Where do we start?
There's not a lot of money for atmospheric microplastic work. We're having trouble with that.
There's not a lot of money for microplastic or nanoplastic work, period. Primarily because it's plastic research, and plastic is potentially an oil and gas, well, most of the time it's an oil and gas product, and therefore slightly political in most realms, and therefore funding is not necessarily as forthcoming as it would be if it was, I don't know, something else, like if we were trying to build wind farms or something. So unfortunately, all of us plastic researchers have got that battle. I think one of the key things is in the last 10 years, so 10 years ago, we were doing marine plastic research. We, as in like plastic researchers in general. Plastic research was in the marine realm. In the last 10 years, microplastic research has started in soil, it started in air, it started in fresh water, and it started looking at human health impacts. All of those only started in the last 10 years. So it's exploded as a research focus, but it is really new, really, really new. So the new things, I guess, the new advances, things like starting to use a Raman to do analysis for microplastic, because most people using an FTIR beforehand and only looking at the big particles, so the ones that you can kind of see rather than looking at the stuff that you can't visually identify easily, like stuff that's smaller than the size of your hair, which is what the atmospherics are. Being able to do things like look in the nano realm, so there's new techniques to analyze nanoplastics, so things like the TD, the Matt Doosan,
PTRMS,
Meteric.
Proton transfer reaction mass spectrometry.
Yep.
That's a bit of a mouthful. But
massive mouthful.
It is a real step forward in that we can now measure nanoplastic, at least the mass at this point in the atmosphere and in the environment.
Yeah. We started doing research and looking into the transport capacity, so doing some modelling using what used to just be standard atmospheric models that you'd use for all sorts of other things. We're starting to basically learn from the old global analysis that has been done previously for atmospherics and for water and soil and everything else, and use those tools to start looking at microplastics, but also to understand the uncertainties about what we know and what we don't know, and how well these tools are replicating what we think this particle does and what we need to create. So because if this particle doesn't function like a single static particle, like a piece of dust, there's quite a lot of parameterization and a lot of model redesign that needs done, like quite a lot. And that's been started. So the guys in NILU that work in the creation of FlexPart, which is an atmospheric model, are doing all sorts of advances to try and enable the parameterization of microplastics in atmospheric modeling, so that we can take a sample from the middle of the ocean, like from the air in the middle of the ocean, or from the air on the top of, say, Mount Everest or whatever.
Maybe a way to get attention is to put some kind of sampling device that would, kind of estimate what someone would breathe in if they were hanging out in a particular area. And if you could see the body burden, you can calculate the body burden of exposure. Maybe that would be helpful.
Yeah, so there are a few studies that have tried to start looking at that. There are more. It's very, very new, as in the last 2 years or so. There's a study done with a mannequin that's tried to quantify the amount we breathe in. They put basically petri dishes out on the table while you're eating dinner and showed you how much plastic has fallen on your food, therefore the equivalent that you've eaten in that time. I think the problem is that it doesn't equate to, well, what does that mean to me? Like, what does it do? So we don't have the human health impact element down yet. That's the bit of research that I think is going to make a really big leap. Like, nobody is dying of plastic as far as we know. It's not been proven that they're dying of plastic yet. So
it's probably not good for you, right? I mean,
yeah.
There's 2 studies by the Environmental Working Group that I had looked at a long time ago And they had shown, I don't know, it was like a witch's brew of chemicals that even came through cord blood, from mothers to infants, and certainly, older people too. Perhaps that could be an overlay for what you're doing. Look at the plastic component to that.
There's the chemicals that are in the plastic we know are evil, are bad, like do all sorts of nasty things.
It's impossible to pass out which particle is doing us the most harm. They say we've got 9 million people dying per year from black carbon coming from exhausts and wood burning. But how much of that was actually caused by plastic, we don't know.
Yeah.
And how much was caused by the chemicals in the plastic. There's all these non-communicable diseases that we're dying of, but it's very difficult to try and pinpoint which one of those nasty chemicals that we're exposed to is to blame.
Or if it's the raft of them, if it's a cumulative burden. And that's where it's causing the impact. But yeah, unfortunately, it's not quite so much like asbestos. Asbestos, it's like you get it. It's really clearly asbestos. You do get sick, right? We don't have the equivalent of that in plastic. We definitely don't want it either. But if we did, it would definitely draw people's attention.
Well, they have flock lung, which is from inhaling the dust in the factory where they made flocking.
Yeah.
But, yeah. Well,
same thing with coal miners, inhaling coal dust and all that in the mines. If you just had someone and they breathed out into, like a filter paper, like what percentage of these particles get lodged in the lungs and which ones kind of get breathed back out? Has anyone done that where they've looked at, again, what comes out of the exhaled breath of somebody?
No, but we already have the data from black carbon, which is handy, which is where they got their respirable limits of PM10 and PM2.5. Is the PM10 gets caught in the upper respiratory system.
Basically, gets stuck in the back of your throat.
And you cough it back up. But the PM2.5 is past all that and gets down into the bottom of the lung. So we already know that these particular materials in like oysters and mussels and clams pass through the animal to all parts of the brain, the muscles, all of the organs. The very small plastic particles move through the animal.
I mean, they've done that with mice. There was a study that was recently published on mice where they not force-fed, but force-inhaled mice. Basically, they filled their air on a fan full of microplastic particles, forced the mouse to breathe all this plastic air, and then dissected the mouse. And the mouse was pregnant at the time, but they looked at the brain and they looked at all the other different organs and they found plastic in all of these different places. So it's inhaled it and it's managed to go through the respiratory system into the bloodstream and go to all of these different organs and get stuck there, basically. So if it can happen in a mouse, then one would assume it can happen in a human too.
And we are exposed to nanomaterials ever since we started smelting metals. Humans have been exposed to nanomaterials. And what they found was that the plastics moved differently than the silver nanoparticles. It was faster. It got places quicker and stayed longer. So it does behave differently. And, of course, it's carrying the chemicals that it came into contact with in the environment.
And also leaching the ones that it was made with.
Yeah. So DDT, PCBs, mercury, heavy metals, they're all stuck to the plastics.
Yeah.
And now there's the chance that that could be carried through into the brain. And we just don't know how many of them it needs before it has an effect.
Yeah.
But, yeah.
Yeah, because plastic particles act a little bit like little balls of Velcro. As they fly through the air or as they go through the soil or anywhere else, they collect, like preferentially, all of the nasty chemicals and things that they come in contact with. So all of the metal pollution and, as Steve was saying, like DDT and all these other things. If you have a soil particle or dust particle come past, it will preferentially stick to the plastic rather than the soil particle most of the time. So they're really good, like, pollutant collectors. And then we have that like heavily loaded pollutant thing being breathed into our lungs or, inhaled and ingested through our food.
Which goes into our bloodstream.
Yeah. So, yeah.
It's very difficult to model, I'm sure, but has anyone been able to try to model in the lab various mixtures of different microplastics and looked at their, physical and electrical and binding characteristics?
Yeah, there's been a few studies where they've done that and they've actually tested how much the other materials will actually stick to the plastics and how much they will release when put into the stomach, a fake fish stomach that they made. It was quite interesting, actually. But, yeah, they found that it would draw the chemicals out of the food that the animal ate, but it would then release it into the gut, which was quite interesting.
Yeah, and not ideal, really, for the fish.
Yeah, and I mean, I know there's tons of questions. What does this do to the microbiome of the creatures that have these plastics in them? How does it affect it? How do they interact with the microbiome? The ones that get there, the ones that you ingest by eating food. Yeah, I mean, it's endless. There's a lot of questions. Where do you think headway is going to be made in terms of understanding?
Where has it been made?
Yes.
Where is it? Where do you think the big breakthroughs are going to be? What needs to be looked at? And if you had the money to do it, what needs to be looked at most urgently, you think, to really give an estimate of what's going on?
I think we need to step it up and do full human dissections. We need to know where it is in the human body.
How much?
We now have the equipment to do it, the Raman laser and the TDPTRMS. We can actually do the nanoplastics now, and I think it really needs to be done. We need to find out, is it getting into us? Where is it going, and what is it carrying?
Yeah, we know that it passes cell lines. We know it has the potential to change RNA and to modify how cells function, and that replicates its way up to changing behaviours, changing fecundity, changing mortality in species. So
oxidative stress, it's just, yeah.
Yeah. But on top of that, we really need to know where the sources are. So if we're going to do anything about this, we need to know what it's doing to us, but we also need to know where it is worst. Where is the biggest problem? Where's our biggest environmental release? And while we've got lots of theories and lots of little bits of research on that, we don't have a global picture on this at all.
The only thing we do know is that we've got to stop producing it.
Yeah.
Now, there's a UNEP meeting coming up, and they were going to table the idea of a global treaty on plastics to get people to stop producing so much and to start recycling better and waste management handling. Now, the oil and gas industry have started in the background already trying to scupper that agreement. They're trying to get people to not bans in place or reductions, just to focus on the recycling, which in 50 years has not worked one iota. Less than 9% is actually being recycled. And
even if you made a massive improvement to the availability of recycling, and there being more recycling stations that are far more productive, and the recycled material ends up being, valued and used a lot more, there is no way that we can physically recycle the plastic pollution that we make. We just make way too much of it. It's not possible to deal with it with that one bullet. That's just not the answer. It's a part of the answer. You don't stop recycling, but it's definitely not your main activity. It can't be. It was never part of the discussion. When they first made plastic, it was never supposed to be recycled. It was just when a few people saw some plastic laying around that they said, oh, no, we can recycle that. Just put it in the little green bin over there. It'll be fine. Yeah. We'll deal with it. And then they ship it off to Africa. It's like, this is what's been happening around the world. It's shipping to Turkey. The UK ships its plastic to Turkey. Some goes to Malaysia. A lot goes to Africa, and then they were trying to increase the amount they sent to Africa, who can clearly not deal with it. They haven't got the handle on their own waste management, let alone ours. I mean, the flower of Africa is a plastic bag in the tree.
The what of Africa?
The flower of Africa, or the flower of South Africa, is a plastic bag in the tree. Like that, it's a joke that they say in country, but it's actually true. That's what they call the flower of South Africa, is a plastic bag flapping in the tree. That's because they have such a waste problem. And they know that, but they don't have the capacity, the ability, the funding, the support to fix that. It's just not possible. So as far as your breakthroughs that we need in the next, like yesterday, I guess, but in the next 10 years, we need to do the human assessment of what it is doing to us, so we understand exactly where that is, and we need to figure out where it is. So to do that, we need environmental studies done on emission rates of plastic into the ecosystem so that we can see where it's going. And that means that we need to go not just through the marine environment and into the freshwater environment. We need to go all the way through the soil up through the top of the atmosphere and look through that entire cross-section across the entire range of seasons and in socioeconomic areas to understand where this is so that we can map it out. This isn't a one shot. We can just make an assumption over, it being by population. It's not just by population that we release this plastic pollution. Or GDP. Or proximity to rivers, or the fact that you happen to be in a windy place. And there's no one element that drives where we create this. It's way more complicated than that. So we basically need a host of people to go out and just start taking samples so that we can, in a sort of a rigorous way, so that we can figure out what's going on. But to be able to facilitate that, we need our analysis systems to speed up, because at the moment it's really labor intensive to do this analysis, and you have to have a wee bit of training and understand what it is that you're looking at to be able to do it. So the the 70 research papers that have been published to date, I think it's 72 or 73 that we're up to so far on atmospheric microplastics, all those people had to do an awful lot of training to figure out how to analyze these teeny tiny plastics that you can't see. It takes time. It takes a really long time to do this.
It's a lot of effort for the contamination prevention.
And an awful lot of cost for the equipment that we use. It's not cheap. So we need to make a breakthrough in facilitating the analysis of this so that it gets faster and it gets cheaper, so that there isn't this block of research only being done in, top level labs in first world countries, because it doesn't need to be like that. People are completely capable of doing this research in all sorts of different places, but you need the equipment, and at the moment the equipment is stopping most people from being able to do it.
And having said that, if any manufacturers are out there would like to donate one, we'd be lovely to have one.
Yes, yeah. Mobile lab, here we come. That would be amazing.
Well, no one also knows how, I guess, what people consider to be atmospheric pollutants interact with plastics, microplastics, NOx and SOx. Do they have a particular affinity or disaffinity for them? CO2, carbon monoxide, etc. No one's studied this, I would guess, right?
No,
it's
not yet.
An awesome question, and we would love to know, because that'll help our models, the models are just guessing at this point. We've got a lot of assumptions because we don't really know what will happen. And, what's the effect of sulfur in the atmosphere on these particles? Does it just stick to it? Does it make it repellent? Does it break it down faster? We don't know.
Or does it make it sticky so that they all clump together? Yep. We need sort of some funding and a whole heap of PhD students, and then we go let them play in a lab with a box and some air that they can pollute to their heart's content and then just analyze. That would be amazing. And we really need that, but we just haven't got that yet.
Yeah.
Well, very good. What's the best way for people to reach out that have listened to this podcast and want to know more and or help? Where can they go?
You can contact us through the website, www.plasticpollution.news.
And
Twitter handle microplastic 101.
Yes, Twitter always works really well. I'm with the University of Strathclyde, so you can find my email address on the university website. And Steve is currently with the University of Dalhousie doing an OFI fellow. So that's an Ocean Frontiers Research Fellow. So he's got a email on that website too.
Well, very good. Steve and Dee, thank you so much for coming on the podcast. It's a very important topic, and I'm very glad to have met you and spoke with you. Thank you.
A pleasure.
Thank you very much.
Remember, before you go, adding Relax Babe gummies to your daily routine is an amazing way to support your everyday wellness. Get your CBD products from a company who's passionate about making CBD wellness simple, delicious, and routine, so you don't have to worry about anything. Relax Babe is giving our listeners 20% off their first purchase. Use coupon code FINDINGGENIUS with no space, FINDINGGENIUS, at checkout, and you'll save 20% site-wide. Visit shoprelaxbabe.com.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.